first, let me introduce myself. I'm Sanjay Goyal. I'm currently working in Cadence Design System, Noida, as a application engineer, and I'm having more than 8 years of experience in physical design domain. Before Cadence, I worked for Qualcomm, Synopsys, and Cadence as well. So, yeah, this is all about me. So, Suma, you can introduce yourself first.
Okay, sir. Thank you, sir. Myself, I am Sumlata, and I have completed my master's in VLSI, and in 2014, sir. After that, I have worked as a quality assurance engineer, sir, in DRDO, and recently I have completed my physical design training in physical design training from Siemens Private Limited, Hyderabad, sir. And during my training period, I have done 4 projects. One is full chip level, and the remaining 3 are block level projects, sir. And tools which I have used is one is Innovus and Genus, sir. And during my training period, I have learned how to do floor planning, power planning, CTS, and routing. Thank you, sir.
Okay. Upvit, right?
Yeah, yes, sir.
Yeah, you introduce yourself, please.
Yes, sir. Good afternoon, sir. Thank you. My name is Sakare Upvit, and I am doing my MTech in VLSI Design from VIT Bhopal University. And I have not done any kind of internship here. And I have right now covered the digital part, STA, CDC part, and metastability part.
Okay, fine. So you are not specific to PD, but you are open for any other opportunity as well, right?
I'm doing RTL and design and verification course.
Okay. So can you please tell me how should I conduct the interview, one by one, or I can ask random?
So as you wish, randomly also. Fine.
Okay, Suma. So let's start with you. Yeah. Can you please tell me the input required for the physical design flow?
Sure, sir. Sir, STC, sir, and mainly netlist, sir, .stc, .lib, .lef, a UPF file, and TLU file, sir, and spec file, sir. That's it, sir.
Okay. What does STC contains?
Sir, STC contain clock information, sir, and input transition, output load capacitance, and timing exceptions, false path, multi-cycle path, half cycle, min-max delays, and set case analysis. These things will be there in .stc, sir.
Okay. And from where we get the netlist?
From synthesis output is netlist, sir. From synthesis team we get netlist, sir.
Okay. So why we require the netlist to start the PD flow? Is it a must input, or we can start the PD flow without netlist as well?
No, sir. It's a must input, sir. It's a logical interconnections will be there, sir, in netlist. Without netlist, we can't go, sir.
Okay. So, Sakriya, can you please tell me about what are the different design styles we can write the RTL?
Yes, sir. Sir, in Verilog, we have data flow modeling, behavioral modeling, and gate level modeling. And mainly, generally, the most preferred language is the behavioral modeling language in RTL design and verification.
Is this a language or
sorry, modeling the way of writing, describing the digital system.
Okay. So can I write the digital system using languages like C or C++?
Yeah, actually, not we cannot design RTL. I mean, digital electronics code in C because it is hardware-based language, and C are kind of software languages. So
So
that's
what is the difference between them? Like both are language only, right?
yes, sir. Yes, sir.
So why we cannot write the hardware using the software languages like C, C++?
They are not structured in that way to write coding or to describe the functionality of any gate of AND gate or any flip-flops functionality. We cannot, there is no kind of library, we can say that in C or C++.
No, suppose if library is there, right? So what is the fundamental difference? Do you have any idea?
No, sir.
Okay. Okay, Suma, so can you please explain me the PNR flow?
Sure, sir. Sir, we need to import the design, sir, and after that sanity checks will be there, sir. And after the
No,
sanity check,
no. I'm talking about what are the different stages of a PNR flow.
floor planning, power planning, placement, CTS, routing.
Okay, okay. So suppose if we want to start the PNR flow and we want to do the floor plan. So what are the mandatory input requires to start the floor plan?
Floor plan, netlist, sir, dot stc, dot lib and dot left and UPF, sir.
Okay, dot live is mandatory. Can I I cannot start the floor plan without dot live.
Floor plan we can do, sir,
Are you
without
sure?
dot lib. It's a timing. Actually, it contains the timing information, sir.
Okay.
Cell delay, delay, cell functionality, and input transition, output load capacitance. But floor planning we can do without that, sir. Whenever we need to do power planning and when we need to do the timing analysis, it is required, sir. Floor.
Okay. Okay. Why left is required?
Sir, LEF is a physical library, sir. It contains the cell shape, size, all physical related information.
So what are those physical information?
Macro, sir, a standard cell physical information, macro, IO physical information, and TechLEF is also there, sir. Metal layer and via information will be there, sir.
Okay. Okay.
Pitch and metal pitch and metal width.
So what is metal pitch?
Metal pitch means the middle point to if two metals are there, the middle point of the one metal layer to other metal layer, the distance between those two, we call it as a metal pitch, sir.
Okay. 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 So what we do in the floor plan stage?
Sir, we place the macros in the core area, sir, by using the floor plan guidelines, sir.
So directly we start placing the macro in the floor plan. Do we have any other option or other steps before doing the macro placement?
Yes, sir. We need to define the aspect ratio and core dimensions. We need to define, sir.
How we define core dimensions? On what basis?
Sir, If we consider any block wise, block def will be there, sir. Based on the def file, length and width details will be there, sir. So in the floor in floor plan, first we need to define those details, sir.
Okay. Okay.
Specify floor plan. We need to go to the specify floor plan and we need to define those details, sir. Aspect
Okay.
ratio
Okay.
and width the details we need to.
Okay. Then what we have to do after defining the width and height?
And first we need to import the design, sir. After that we go for floor planning. And in the floor planning we need to fly line analysis we have to do, sir. Whereas the tacking macros we need to identify those macros needs to be placed in side by side.
Okay.
And macro should not be placed in the center of the core area. It should be placed.
Why we cannot place the macros in the center of the core area?
To avoid congestion and the timing violations, because while placing in the middle of the core area, the routing length will be more, sir. So to avoid that,
so why the routing length will be more if we place the macros in the center of the area?
Sir, while the interconnecting from macros to standard cell, those length will be increased, sir, and routing length will be increased, sir.
No, why so it will be increased? That is what I am asking.
So,
cannot I route the standard cell and macros over the macros?
But congestion problem will be increased, no, sir. It will be if the macro will be the center of the core area. If any standard cell will be in the lower area, so it will be routed through. Routing will be difficult, sir, and area will be. We need more area to route, sir. When if we place it corner of the core boundary. It will be connected easily to, and the routing length will be, we can reduce. Congestion issues also we can reduce, sir.
Okay. Okay. Okay, fine. Go ahead. Then what else we do in the floor plan stage?
And the halo, we need to place the halo, sir. And some guidelines will be there, sir. Notches should be avoided in one of the guideline, and R270 and R90 orientation should not be allowed, sir, as per the manufacturing guidelines.
Okay.
Tacking macro should be placed side by side. That is one of the points, sir. And after the placing the macros, and we need to place the halo, sir.
Okay.
To avoid overlapping, we use halo, sir.
Okay. What else we do in the floor plan?
Floor plan. That's it, sir.
Okay, so we do the we define the width and height of the core. We do the macro placement. What else? Anything else we do?
Macros placement we do, sir, and halo we place, and after that we go for power planning, sir.
Okay. And after that, what we do?
Power planning we do. After that, standard cell placement we do, sir.
Okay. Okay. So that comes in the standard cell placement comes in the placement stage, right?
Placement stage, sir. Yes.
So what else we do in the floor plan stage before the standard cell placement?
Sir, VDD VSS stripes we need to add, sir.
Okay. Do we do any kind of physical cell placement? Some physical cells are there.
Physical during pre-placement, yes, sir. We do the end cap cells we need to place, sir.
Okay. Why we require the end caps?
Sir, to maintain the NVL continuity, we place end cap cells, sir. To avoid opens also, we use end cap cells at the corners. Core core boundary corners sides we place handicap cells, sir.
Okay.
And one block and other block continuity to avoid continuity issues, we use handicap cells, sir. And physical damage, to avoid the physical damage of cell, we use handicap cells, sir.
Okay. And what are the other cells we place apart from the end caps?
Decap cells, physical cells are decap cells, tie high, tie low cells, spare cells, filler cells, and well tap cells also there, sir.
Why we require the decap cell?
Sir, to avoid IR drop, we use decap cells, sir.
Okay.
It acts as a
So
capacitor.
how these cells help to avoid the IR drop?
Sir, we place these cells in the VDD VSS rail, sir, and it acts as a capacitor, sir, and it stores the it stores the energy, and whenever it required, it will avoid the IR drop, sir.
Okay. Why we require the tap cells?
Sir, well tap cells used to avoid latch up, sir.
Okay. Okay. So, Upavit, can you please help me to understand what is the difference between Verilog and VSDL?
Yes, sir. They are both hardware description language, but one is weakly coded and one is hard. I mean, the coding part, it is very VSDL is very cache sensitive. And if you write small n and capital N, it will take as a different number character.
Okay.
But in Verilog, it's like similar. Small n and capital N character, it will almost consider similar, and coding in Verilog is weakly. I mean, it's like basic of C kind language.
Weakly means?
Easily, I mean, coding part is very much easy in Verilog.
Okay.
And in VSDL, it's a little bit of highly algorithms are very much difficult in VSDL.
Okay. So do you know Verilog coding? Which one you know?
Yes, sir. Basic. Yeah, yes, sir. I know Verilog.
Verilog. Okay, go. You know Verilog. Okay. So what are the data types in Verilog?
Yes, sir. Data types. Reg, int. There are similar to C. Int. Int. Input, output, in out. Int.
What is the
Logic.
difference between flip-flop and latches?
Flip-flop and latches. Difference is in the how we are giving the clock. I mean, latch is level triggered clock, level triggered, and flip-flop is edge triggered device.
Okay.
So in latch, if input is changed, then output is simultaneously changed. But in flip-flop, the output will only change when the edge comes.
Which edge comes?
I mean, if it is rising edge, then when rising edge comes, then only the input will be changed in the flip-flop.
Okay.
And if it is if it is based on falling edge, then it will change its output when the falling edge comes.
Okay. So, Suma, so how do we validate whether the floor plan is good to go, or do we need any requirement for improvement?
Sir, we need to check the congestion, sir, and also density, sir.
Okay.
Density should not be more than 70%, sir. And based on that, if congestion is also more, then we need to do again the floor planning, sir.
Okay. So how do we check the congestion? I mean, so we have to do the placement, or in the floor plan stage only we validate the congestion?
No, sir. After placement, we need to check the congestion, sir.
Okay. Okay. So what we do in the placement stage?
We place the standard cells, sir, in the placement stage.
And what else we do?
And the first stage, one is prior placement will be done, sir. After that, a detailed placement is done, sir. Placing the standard cell in the core area, sir.
Okay.
And in that only, if it is a full chip level, we need to add ring and stripes, sir, and also S route also we do, sir, special route.
Okay. So after placement, what is the metrics we have to check?
Verify connectivity we have to check, sir, and the congestion density also we have to check, sir. Any opens it is there, we need to verify, sir. Any dangling errors, if we haven't placed any handicap cells, we can get antenna dangling errors, sir. And opens also we get, sir. So
those placement stage opens
after placement, sir.
But how we will get the opens if we have not routed? We have not done routing, right?
Sir, if VDD VSS stripes we add, no, sir. Power planning. After power planning, we go for placement.
Okay.
So VDD VSS connectivity issues will be there, no, sir. Then there it will be, it shows open, sir. So any VDD VSS connections are the issues are there, we get opens. Those things we can
opens.
We have to clear,
no, I don't think anything is required related to VDD VSS.
Okay.
No, we don't check opens after placement.
Okay. Actually, during the
apart from congestion, what we check? Density, congestion, and anything else? Density. Timing? We don't check timing.
Timing we can check, but that much we at placement stage we haven't fixed those timing violations, sir. But we will check, sir.
No, so suppose if I'm getting a WNS of minus 1.5 NS, so will I not check it in the placement stage, or will I not fix it?
No, we can fix it, sir, by optimizing. Opt design one command will be there, sir. We can.
So we have to check, right? We have to check the timing in the placement stage.
Okay. Yes, sir.
Do we check the hold as well in the placement?
No, sir.
Why?
No, sir. Actually, clock, we define the clock in CTS, sir. After hold will depends on generally setup only will come, sir, in the placement stage. After CTS, we can check hold, sir.
No, after CTS also we can check, but what I am asking is why we don't check before CTS.
Okay. Means that I'll go through it, sir. I'm not able to recollect it.
Okay.
I'll go through it.
Okay. Okay. So, Shakriya, do you know the ASIC flow?
ASIC design flow?
Yes.
First of all, there is a circuit level, then gate level.
No, man, you are not prepared, I think, for the interview, right?
Yes, sir.
How long have you been preparing for the interview?
Sir, from 2 days I am revising the concept.
The asset flow is the basic, right?
Yes, sir. Yes. I just
Interview is nothing like that. The interviewer is going to ask a big things, right? He will check only what you know in the basics.
yes, sir.
Right? Right? I asked another question where you were not able to answer. What is that question? You were talking about reg and int.
Yes, sir. Data type.
Right.
Yes, sir.
So focus only on the basics, right? And get some confidence by learning the basics. I don't think that you are well prepared. I believe you should just take some more time and get prepared yourself.
Yes.
Right? Yes, Uma. So, what is the next step after placement?
After placement, it is CTS, sir.
Okay.
And after CTS, it is routing, sir.
No. So, I mean to say, what we do in the CTS.
Sir, we need to propagate the clock to all registers, sir, with maintaining minimum skew and minimum insertion delay, sir.
Okay. Why we want to maintain the minimum insertion delay?
To meet the timing, sir, to meet the setup and hold requirements, we need to maintain minimum skew and minimum insertion delay, sir. Targeted values will be there, sir. So it should not be more than the targeted values.
What information we have to provide to the CTS stage to begin with the CTS?
Insertion delay, sir. The skew, targeted skew.
Okay.
And buffer details and NDR rules. And
what is NDR rules?
Non-default rules, sir.
Non-default rule means what?
It's a NDR rules and double width and double spacing will be there, sir.
Okay. Why we require NDR rules?
And, to avoid crosstalk and IR, sir.
How it will avoid the crosstalk if we use the double width and double spacing?
Sir, crosstalk, generally crosstalk is nothing but when two parallel nets are there, one is aggressor and one is victim. So one net will be affected by the other one, sir. So to avoid that, we can spacing between those parallel nets we can increase, sir. If we increase that, we can avoid crosstalk, sir. And one more is electro migration, sir. Migration we can avoid by increasing the width, sir.
So what is electro migration effect?
Sir, due to continuous flowing of current, atoms collision will due to the atoms collision, there will be opens and short may occur, sir. To avoid that, sometimes metal brokerage will happen, sir, due to that. So to avoid that, we need to maintain the width, sir. So
Okay.
to increase the width, we can avoid electromigration, sir.
Okay. Sakriya. So, what do you understand by the terms like RAG and the wire?
Yeah, reg term is used for to store one bit for temporarily, and wire is used just to transfer the input data to the output in the Verilog part. And in test bench also we are using the reg and wire.
Okay. Okay. Subha, do we need any special kind of cells in the CTS stage?
Special kind of buffers, sir. Buffers and
What are they called? Buffers.
in CTS. To meet that, sir, after CTS, we need to check setup and hold, sir. To meet that, we generally we need to use HVT cells, LVT cells. For meeting the timing, we use LVT, sir. To meet the power, we use HVT, sir. And
No,
buffer
no,
also.
no. I'm not talking about that. I'm talking. We need some special kind of cells in the CTS stage, right? Do you know the name of those cells?
No, sir.
Clock buffers, clock inverters.
Yes, sir. Clock buffers and clock inverters, I know, sir.
What is the clock buffers? Means why they are called clock buffers? What is the difference between the normal buffer and the clock buffers?
Okay, sir. In the in clock buffers, rising and falling times will be equal, sir, in clock buffers. So that is not happening in the normal buffer, sir.
And why we require that in the clock?
To avoid pulse width violations, sir, we required clock buffers and clock inverter.
Okay. So, then what we check after the CTS stage?
Sir, setup and hold, we need to check, sir.
Okay. And suppose if I'm getting the setup violation, then what are the options I have to fix those violations?
Sir, one technique is, sir, instead of HVT, we can go for LVT cells, sir, and upsizing, sir. One of the technique is upsizing and buffer insertion, sir.
What do you mean by upsizing?
Sir, but if, for example, any buffer is having X4, X6, so the size, the drive strength, we have to increase the, we can increase, sir, so that timing we can meet, sir. If any X2 cell is there, so by increasing the size means we are increasing the drive strength, sir. So driving capability of that cell we can increase so that we can meet the timing, sir.
Okay, how does the tool calculate the delay of a cell?
Cell delay tool. Generally, sir, cell delay information will be there in the .lib file, but how it calculates that I'm not aware of it, sir. I'll go through it, sir, once.
Cell delay information is there in the .lib file. Are you sure?
Yes, yes, sir, I'm sure, sir. .lib contains cell delay and cell functionality, input transition, output load capacitance, those details, PVT conditions, those details will be there in .lib, sir.
Yeah, that is what I'm saying. Those conditions, those information will be there, but I think delay value will not be there. The tool does not take, or the library does not contains delay information. the delay information is calculated by the tool based
Okay, sir.
on the input transition and the output load. So the cell delay depends on two parameters, that is input transition and the output load. And these two information is available in the dot lab. So based on the what is the input transition and what is the output load of that cell, the tool will calculate the delay, and that delay is used for calculating the timing.
Okay, sir.
Okay.
Okay.
So yeah. Yes. So we were talking about the ways to fix the setup violations, and you talked about the uses of LVT cells, then doing the upsizing. What else we can do?
Buffer insertion, sir.
Buffer insertion. Where we have to do the buffer insertion?
Wherever the longer net is there, we can insert the buffer, sir.
So what it will do?
It will we can fix the timing violation, sir.
How? How it will fix the timing violation by inserting the buffer?
Okay. Say, but sir, for example, any longer net is there, sir. To me, first from start point to end point, it will take some time. But whenever we are inserting in middle, we are inserting any buffer, so that time will be reduced, sir.
Are you sure?
Yes, sir. For longer nets only, it will be reduced, sir. But if we use for the shorter net, it will be more, sir. But we won't use for a shorter net, short net, sir. If it will be used for only for longer net, sir.
Yeah. So the reason to use the buffer is the input transition will be very high.
Okay, sir.
Okay. So to reduce that, we have to insert the buffer so that it can amplify the signal strength, right?
Okay.
Okay,
Yes, sir.
that's how the delay will be reduced, not because the timing will be very high for the longer net, right? The timing will be high because the transition will be high.
Okay, sir.
It will take more time to transition because longer the net, the higher the resistance, right?
Yes, sir.
So we break that resistance.
Okay. Okay, sir.
Okay.
Got it.
Yeah. So what else we check in the CTS state? Do we check the congestion?
We can congestion after routing. We check, sir. In CTS also we can check, sir. But generally after routing congestion, in my project I have checked after routing, sir, and after placement I have verified, and after routing I have verified, sir.
Okay. Okay. So what we do? So next stage is routing, right?
Yes, sir.
Okay. So explain routing. What we do in the routing stage?
Sir, in the routing stage, all signal pins will be, all physical connections will be established, sir. In the routing stage, and there will be two routings will be there, sir. First, after placement, we do normal one detailed routing will be there, and one virtual routing will be there, sir. So based on the virtual routing, congestion we can analyze, sir, whether it is within the required within the required limit it is coming or not. We will verify, sir. In the detailed routing, we route all the physical connection of signal pins, sir.
Okay. Then what we do in the routing stage after that?
And after routing, we will verify the congestion and set up and hold. Timing we need to verify, sir.
Suppose if I'm getting congestion in the routing stage, right? So
Okay, sir.
what should I do? Means what can be the possible reason?
Sir, generally cell padding one of the technique to avoid congestion, and blockages is also one of the techniques, sir. So
But that should not be used in the routing stage, right?
yes, sir. Sir, mostly, sir, early global route after placement, we do early global route, sir. In early global route, virtual tool will do the virtual routing, sir, and based on that tool will estimate the congestion, sir. So in the placement stage itself, we have to fix the congestion, sir. And if anything is there, we need to place the blockages or we need to do the cell padding, sir. So most after
No, that is what you are talking about, the placement stage, right?
Yes, sir.
Suppose if I am getting the congestion in the routing stage, then what can be the possible reason for that?
Sir, routing blockages we can use, sir.
Okay. Okay. What else we check in the routing stage?
Setup, sir, hold.
Okay. And
Antenna violations, any antenna violations are there. You can verify, sir.
okay. And what about the DRCs?
Yes, sir. I forgot, sir. DRCs we need to check, sir.
Suppose if I'm getting 10 lakhs DRC at the routing stage, how you are going to fix them?
Sir, in DRC's minimum width, minimum spacing, those things will be there, sir. We need to first where we are getting and actual how much it is coming and required how much. So we need to find out that net and we need to go to that net and we need to cut that metal and we need to adjust it, sir.
No, suppose if I'm getting 10 lakhs,
Okay.
10 lakhs is a big count, right? It's nothing like a 1 or 2 or 5. So I can do it manually. So
Up to design we can go, sir. Optimization.
After optimization itself, I'm getting 10 lakh TRC. So obviously the tool will not be able to fix them. Then what can be the possible reason for this 10
Floor
lakh
planning,
TRC?
we need to do the floor planning, sir. Best floor planning is one of the.
No, so what is the region in the floor plan? Means the possible region in the floor plan. What can be the possible region?
We need to, sir, good floor plan means we need to follow all the guidelines, sir. And to avoid these errors in the floor plan stage itself, we have to take care, sir.
Okay.
To avoid mainly.
So because we are getting this number of DRC, which is not feasible or viable, so probably the routing grids are not created, routing tracks are not framed correctly as per the technology, right?
Okay, sir.
So the tools are not getting placed properly on the routing tracks. There is a mismatch between the technology and the routing track. So we need to check that. Some basic level information is missing. Otherwise, if this kind of information is provided correctly, we will not get 10 lakhs or something like big amount of DRCs, right?
Yes, sir.
We are getting 100, 200 DRCs, that is fine. That can be fixed by doing some optimization, some manual fixing, some doing some changes in the VRs, some incremental routing. But 10 lakhs kind of thing means there is some big thing, big issue in the floor plan, right? Related
Yes.
to the track creation or the technology information or the technology guidelines, right?
Yes, sir.
Yeah. So I think I am done from my side related to this PNR interview. Do you have any question to ask?
Sir, actually, sir, I have worked a couple of years in different fields, sir. Now I want to shift my domain to VLSI, sir. How the opportunities will be, and now I am suffering to get calls, sir. So what are the improvement areas for me? And one more this thing, sir, and how I need to improve myself, and how to get the for getting calls. What I need to from my side, what I need to do.
Okay. So you did your MTech in 2014, right?
Yes, sir.
And after that, how many years you work?
Sir, up to 2022, I worked, sir, in quality department.
So you have 6-7 years of experience in that
Yes,
department.
sir. Yes, sir.
Okay. So then why you why you want to change to this domain after having this much experience?
Sir, I'm interested in VLSI, sir. So that purpose only I have completed my masters in VLSI. After that, I got an opportunity in serve in defense, sir. So at that time, I have joined in defense. So now I want to change my domain, sir.
Okay. So the thing is, because it's a big gap between your qualification and your interested domain, right? That is PD. Big
Yes, sir.
difference is there. So obviously, it will be difficult for a product-based company to hire you. Means it's nothing. It's not. I'm not saying that it is impossible, but the chances or the opportunities might be very less. So I believe for a quick start, you can try with any service-based company, right? So because you don't have the big gap between your job and your college degree, you work in other domain. Now you want to move to this domain, and you have already completed your basic level training, right, from any institute, right, for
Yes,
the
sir.
PD domain.
Yes.
So I think for a quick ramp up or a quick job, you should check with the service-based company like Mirafra, Altron, Capgemini, or any other which is available in the Bangalore, right? Because there are huge demand, huge
Okay, sir.
opportunities are there, and you will get a good time to learn and uh, grow in the industry, right? It's nothing like that. Once you join only the product based company, then only you will grow. I have seen there are various guys who have started their journey from the service based company, and they have grown too much. So you can start, you can forward your resume to them, and probably they might give you a chance, because if you are having a good understanding of the basic of PNR flow, then I don't think they will have any issue to give a chance, right? So
Okay.
don't wait for too much for the product based company. You can start your career, because once you learn the job, you learn the work for suppose 2 years, right? Then obviously you can move to any product based company after 2 years or 2.5 years, like that, right?
Okay.
So
Okay.
you can follow up with the Mirafra, Capgemini, or any other. Like there are various companies who are working in the service industry in Bangalore for VLSI PD domain, right?
Okay.
As far as technical experience, technical knowledge is concerned, my feedback is that you are good, but lagging somewhere in the confidence, right?
Okay, sir.
Clarity in the concept is little missing. Yes, you have the information, and I'm really impressed that you have a good understanding. But to crack the real interview, probably you might need to put little more efforts, right? Starting from the basics, you should have a clear understanding what is the information lib contains, or the left contains, or the netlist contains, or the SDC contains, right? Why we require this information, and in the each stage, like I talked about floor plan, you talked only about that you started with the macro placement. No, there are at least 9 to 10 steps in the in the floor plan stage only, right?
Yes,
Right.
sir.
So
Yes.
theoretically you should know that these are the things we have to do. When I talked about the, when I only checked with you that do we need to place some pre-place cells like WellTap and then only you told about that, but you were missing from that side, right?
Yes, sir.
So you should theoretically know what are the what is the input and output of each stage, what are the different tasks we do in each stage, and how do we validate the metrics of each stage, right?
Yes, sir.
Each stage of PNR flow itself is a one domain, right? I have worked
Yes.
in Synopsys for 5.5 years, and there are various teams who are working in the particular stages. Like one team is working in the CTS stage, one team is working for the placement stage, one team is working on the routing stage. From the tools point of view, not from the design point of view, from the tools point of view, right? So
Yes.
so we should have more clarification, clear understanding regarding the each input and output of the stages, right? And the how do we validate the metrics of the each stage, right? Like
Yes.
I checked with you, how do we check the timing of the placement, right? You talk that no, we don't require that, we cannot fix that, right? We
Yes,
do,
sir.
right? Why we don't check the hold violations also, right? There is a clear reason for that not to be checked, right? So these, the question will be the same. They are not going to ask you what is CPR kind of things, right?
Okay,
They
sir.
are not going to ask you what is OCV, on chip variation effect. They might ask you should have a basic understanding, but the more basic information you have related to the inputs required, output required, and what actually we do in the each stage, like we check the congestion, we check the density, we check the routing net length, we check the timing, right?
Yes, sir.
We check the DRVs. What are the DRVs? How the tool do the placement? What are the different stages the tool does when doing the floor plan, or when the tool does the placement, right?
Yes, sir.
So try to get a more understanding of each stage. I hope that you will be able to crack the interview very soon. Best of luck.
Thank you, sir.
Yeah.
Sir,
And
sir, after placement, that hold, why we generally.
because yes, so because you told that we do check hold after the CTS stage, right? But
Yes, sir.
nowadays I can counter this question in the same way that we are doing the CTS or the clock we are synthesizing the clock in the placement stage itself, right? But
Yes.
the thing is that we don't have the real delay information from the source to the clock endpoints, right? So
Yes.
the clock is not synthesized, so we don't know what is the insertion delay, actual insertion delay between the clock capture path and the clock arrival path.
Okay, sir.
Okay,
Okay,
so
sir.
that delay information is there. We cannot estimate what is the delay estimation, and that's how we cannot check the, because for hold checking we require the skew difference between the arrival and the capture path, right?
Yes, yes, sir.
So that information is not available because clock is not synthesized, and the tool cannot estimate that delay information.
Okay, sir.
Okay, yeah.
Thank you, sir.
Yeah, Sakriya. Sorry, I could not ask you more question because you are not from PD background, right?
Yes, sir.
So, for what profile you are working for? You are looking your job.
Sir, in RTL design and verification.
RTL design and verification.
Front end part for
Yes.
front end.
Yes. So for you, my feedback is that you are not well prepared for the interview as of now. You should little bit go for better preparation, right? You should give some more time, starting from the basics. And basics start from the ASIC flow, right? At least you should know what is the ASIC flow. You want to give an interview
Yes,
from
yes.
for the front end design, and you don't have any idea about the ASIC flow. So first, you should focus on the basic of Verilog. What is the ASIC flow? What is the different design styles? right? How we can write the Verilog code for different kind of headers. Can you write the code for half header right now? Verilog code for the half header?
Yeah, sir, I can write.
Okay.
Wait a minute, I will page. Sir, can you see the
Yeah, I can see module half header.
sum and carry?
Which design style you have used for this?
Sir, actually, this is only data flow modeling. Actually, yeah, assign keyword I just forgot to use.
Yeah, that is what I am asking. So,
Yeah, data flow modeling. Assign
yes,
keyword will. Yes.
right. Yeah. So, my feedback for you too is go for little more preparation, get some confidence, right? When you introduce yourself, you should have some more content to tag where I belong to, right? Which year I completed my BTech, right?
Yes.
Right, I'm doing currently MTech, and what are my areas where I am having some skills, right? Yeah,
Okay, sir.
yeah. So I think you should focus more on this side. Any question you have?
No, sir, I will try to revise the basics. I just forgot actually. I have seen the ASIC design flow, but right now while revising, I just couldn't see that. That's why.
Yeah. So if that can be your first question itself, right, and it will leave a very bad impression on the interviewer, right?
Yes, sir.
Yeah. Okay. Do you have any
Thank you.
question?
No, no, sir.
Okay, fine. I am done from my side. Thank you.